It's entirely temperamental. It's going to detonate. No, it's not going to give me an opportunity to go for that. The thing is, it very well may be tomorrow, it very well may be during this transmission, and it would sparkle like a second sun overhead. The James Webb Telescope has recently detected an unexpected 250% expansion in the brilliance of Betelgeuse, the red star situated at the shoulder of the Orion constellation. This unconventional behavior has ignited energy for an intriguing display. Some suggest the sudden increase in brightness could indicate that Betelgeuse is preparing to go supernova, but the exact timing remains uncertain. Specialists hypothesize it could happen soon. Join us as we explore the depths of space and unravel the mysteries surrounding this celestial giant. Betelgeuse has the potential to reshape how we understand the universe. Despite its name not being widely known, you've probably appreciated its brilliance. A brilliant ruddy glow shining brightly at the shoulder of Orion, a notable star grouping. Betelgeuse's immensity is staggering. If placed at the heart of our solar system, its outer surface would extend past Jupiter's orbit. This giant star, easily noticeable, continues to enamor us. Unlike most stars, Betelgeuse changes in brightness over time due to its proximity to our system. Named a semi-regular variable star, its brilliance fluctuates consistently, moving toward a potential great breakdown in a supernova explosion. Recently, Betelgeuse has become even more captivating due to surprising variances in brightness. These variances include a significant surge on May 20, 2023, when researchers observed a staggering 142% increase in brightness, followed by a later update showing a 150% increase. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, notes that Betelgeuse currently ranks as the 7th most brilliant star in the night sky, climbing 3 places from its usual 10th position. From the southern half of the globe, Betelgeuse shines brightly in the afternoon sky, easily visible at the shoulder of the Orion group of stars. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, highlights Betelgeuse's significance. It offers a rare opportunity to study the final phases of a massive star's life, providing valuable insights into red giants' behavior before they explode as supernovae. When Betelgeuse eventually detonates, it could become incredibly bright for about a week, possibly casting shadows at night. This prospect has both amateur stargazers and professional astronomers eagerly anticipating the event. Heidi Morris, a researcher at Los Alamos National Laboratory and president of the Padaro Astronomers and Cosmology Club, notes the enduring interest in Betelgeuse's brilliance fluctuations, a phenomenon unnoticed for centuries by different cultures. Currently, Betelgeuse's brightness cycle lasts about 130 days, significantly shorter than its usual 400-day cycle. These rapid changes provide astronomers with a unique opportunity to study this celestial phenomenon in detail, shedding light on the final stages of a star's life. The surprising behavior of Betelgeuse began in 2019 when it violently ejected part of its outer atmosphere. These fluctuations in brightness are abnormal for Betelgeuse, raising questions about whether it will detonate into a supernova. According to a paper written by Dupree and other researchers from Harvard and the University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse returns to its normal 400-day brightness cycle. Since the extreme darkening, Betelgeuse has displayed its behavior concerning light and radial speed has modified. Despite its capricious behavior, Betelgeuse remains a massive red supergiant star going through the final phases of rapid development. As it depletes its fuel, the core will collapse under its immense mass, resulting in a supernova blast that could eclipse entire galaxies. The timing of this blast is uncertain, as noted by Dr. Peer, a professor of cosmology at the University of Portsmouth. Predicting supernova events remains challenging, given the limited historical data and the complexity of stellar evolution. Betelgeuse is currently undergoing fusion processes, continually evolving through elements like helium, carbon, oxygen, silicon, and iron. As a red giant star, it fuses helium into carbon in its core, a process that takes millions of years. Eventually, it will advance to fuse heavier elements until it can no longer sustain fusion reactions, leading to gravitational collapse and possibly forming a black hole or a neutron star. While some speculate about Betelgeuse's impending explosion, Historical records show it has been growing redder over the past 2,000 years, suggesting it might take considerable time before it goes supernova. NASA estimates suggest that Betelgeuse is not expected to explode for another 100,000 years, offering reassurance that its explosion is unlikely to occur within our lifetimes. In spite of the uncertainty, Betelgeuse's behavior continues to fascinate researchers and inspire advancements in our understanding of stellar evolution. Dr. Sarah Webb reminds us to stay open to possible outcomes, even as we acknowledge the improbable likelihood of witnessing Betelgeuse's explosion within our lives. Remaining mindful of its changes may lead to further scientific breakthroughs, reminding us to keep hope alive for new discoveries in the universe. It's crucial to understand that our observations of Betelgeuse are essentially glimpses into the past. The light we see from the star is over 600 years old. Theoretically, Betelgeuse may have already exploded, and we wouldn't yet be aware of it. While this possibility exists, it is far from certain. History has shown us that our assumptions in astronomy can be challenged. Prior to 1987, astronomers believed only red supergiants could go through supernovae. However, that year a massive blue star in another galaxy exploded, surprising the academic community. There is still much to learn, and surprises may lie ahead. Observing Betelgeuse and other massive stars allows us to expand our understanding of celestial phenomena. Regardless of the absence of an imminent explosion, Betelgeuse's current behavior is captivating. Its fluctuation between dimming and erupting reveals fascinating physics. The fact that stars pulsate on human timescales is remarkable. While Betelgeuse is currently much brighter than expected based on its usual 400-day cycle, there's hope it will eventually return to this cycle. However, it is struggling to do so. Later observations have suggested that Betelgeuse may be in a late stage or approaching the end of the core carbon burning cycle. This stage involves the conversion of carbon into heavier elements like oxygen and magnesium. If this is indeed the case, scientists predict a core collapse leading to a supernova explosion that could happen within a few tens of years. However, the exact phase of Betelgeuse's evolution remains difficult to determine, and uncertainties persist. The possibility of witnessing Betelgeuse's explosion remains unclear, as the carbon-burning phase can last up to 1,000 years, and the study suggesting an imminent explosion has not yet been accepted for publication. Nonetheless, considering the potential for Betelgeuse to become a supernova is thrilling. It would be an unprecedented event visible even during the day for several days. When the event arrives, the initial signs of the supernova's appearance will be subtle but unmistakable, with neutrinos sweeping across Earth as high-energy photons escape from the expanding cloud of celestial debris. Betelgeuse will gradually grow brighter in the night sky, potentially reaching peak brightness 10,000 to 100,000 times its usual brilliance within just a few weeks. This scene will shock anyone lucky enough to witness it, marking a pivotal moment in cosmic history. The remnants of Betelgeuse's explosion could be as bright as a quarter or half of a full moon, packed into a single point of light. Incredibly, this radiance would be visible during daylight, casting dramatic shadows at night. Predictions suggest it may be 15 to 25 times brighter than Venus, currently the second brightest object in the evening sky. The display of Betelgeuse's explosion would linger in our view for about 100 days, captivating space enthusiasts and offering a unique opportunity to observe the aftermath up close. Fortunately, Betelgeuse's supernova would not pose any threat to humanity, as it is still significantly far away. Optics and telescopes would allow us to observe the event for an extended period without harm. However, such a dramatic event would not go unnoticed. Supernovae were often interpreted as ominous signs, and Betelgeuse's demise could inspire fascinating reactions worldwide. Astronomers believe it could even reignite widespread interest in stargazing, awakening people from their ignorance on a global scale. Betelgeuse is not the only red supergiant in our galaxy. Others, like Antares, could explode before it does. In reality, our Milky Way should observe a supernova roughly every 50 years, yet we haven't seen one in the last 400 years. However, we've observed the remnants of past explosions, indicating that we are overdue for a remarkable celestial event. It's only a matter of time before the next star puts on its spectacular show for the universe to witness. Betelgeuse's history is rich with significant events, including the dramatic darkening in the fall of 2019. This sudden decrease in brightness baffled astronomers and sparked speculation about its potential explosion. Although Betelgeuse's brightness returned to normal by April 2020, the reason for its dimming remained a mystery until further observations shed light on the phenomenon. Skywatchers can easily spot Betelgeuse from their backyards, providing valuable observations for researchers to gain a deeper understanding of the star and its dramatic changes. Scientists rely on observatories like the Hubble Space Telescope to monitor Betelgeuse's behavior. The fascination with Betelgeuse is not just about its potential to explode, but also about the incredible opportunity it presents for scientists to study the final stages of a massive star's life. This giant star, located approximately 640 light-years away from Earth, is one of the most well-known examples of a red supergiant in our galaxy. The fact that it is in the later stages of its life makes it an extraordinary subject of research for astrophysicists. In contrast to smaller stars, which can last billions of years, massive stars like Betelgeuse burn through their fuel much more quickly, living only tens of millions of years before exhausting their nuclear fuel. This rapid life cycle means that observing stars like Betelgeuse can give astronomers a rare glimpse into the dynamics of stellar evolution. Betelgeuse's instability is an intriguing aspect of its behavior. Astronomers have observed several unusual changes in its brightness over the years, which has led to intense speculation about what is happening beneath its surface. The most notable of these fluctuations began in 2019 when Betelgeuse dimmed significantly. While some speculated that the dimming was an indication that the star was about to explode, others believed that it was caused by changes in its outer atmosphere, possibly due to a massive outburst of material. These changes are still being studied as scientists are trying to determine whether they are the result of a natural stellar process or something more dramatic, such as the imminent collapse of the star's core. In addition to the irregularities in its brightness, Betelgeuse has been the subject of detailed observations using advanced technology, such as the Atacama Large Millimeter/Submillimeter Array, ALMA, and the Very Large Telescope, VLT, in Chile. These instruments allow astronomers to study the star in unprecedented detail, providing insights into its outer layers and the complex processes that drive its variability. For instance, scientists have been able to study the star's outer envelope, which is rapidly expanding and contracting. These movements might be caused by convection currents within the star's atmosphere as it struggles to maintain its energy balance. The red supergiant's irregularities are also associated with its size and mass. Betelgeuse is about 1,000 times the size of the Sun, and its mass is between 10 to 20 times that of the Sun. Because of its massive size, it undergoes unique processes that other stars, particularly smaller stars like our Sun, do not. The core of a star like Betelgeuse is extremely hot, and as it runs out of fuel, it starts to burn heavier elements like carbon and oxygen. Eventually, it will reach the point where it can no longer sustain fusion, and the core will collapse under the force of gravity, triggering a supernova. However, this collapse is a complicated process, and the exact moment when Betelgeuse will reach this stage is still a mystery. The star could go supernova tomorrow, in several years, or possibly even centuries from now. What's fascinating about studying stars like Betelgeuse is that they provide key insights into how stars live and die, a process that has direct implications for understanding the life cycles of other stars in the universe. For example, when Betelgeuse eventually explodes, it will release a tremendous amount of energy, much of it in the form of neutrinos, tiny, nearly massless particles that can pass through matter without interacting. These neutrinos would be detectable here on Earth, providing scientists with an unprecedented opportunity to study the physics of supernovae in real time. One of the most captivating aspects of Betelgeuse's potential explosion is the sheer scale of the event. When the star goes supernova, the amount of energy released will be so immense that it could briefly outshine an entire galaxy. The explosion would release a burst of radiation, including gamma rays and X-rays, that would be detectable from Earth, even though the star is hundreds of light-years away. This event would be so bright that it could potentially cast shadows on Earth for a brief period, something that has only been observed in rare instances of nearby supernovae. While this explosion would be a spectacular sight, it is unlikely to pose any danger to life on Earth, as Betelgeuse is far enough away that its radiation would not affect our planet's atmosphere. As scientists continue to monitor Betelgeuse, they are also learning more about the dynamics of red supergiants in general. While Betelgeuse is one of the most well-known examples, it is not the only star in our galaxy undergoing similar processes. Other massive stars, such as Antares in the constellation Scorpius, are also in the final stages of their evolution. These stars, like Betelgeuse, are part of a much larger population of red supergiants scattered throughout the Milky Way galaxy. By studying Betelgeuse and other stars in this category, scientists hope to gain a better understanding of the fate of all massive stars and the impact their explosions will have on the surrounding environment. There are still many uncertainties surrounding Betelgeuse's future. Although the star is undoubtedly heading toward its eventual demise, the exact timeline remains unclear. Some astronomers have suggested that Betelgeuse could go supernova within a few decades, while others believe it could take much longer. In any case, the event is likely to be a once-in-a-lifetime spectacle, visible to observers around the world and offering a unique opportunity to study a supernova up close. In addition to the scientific interest, Betelgeuse's eventual explosion could also have a cultural impact. In the past, supernovae have been interpreted as omens or signals from the heavens, and it's possible that Betelgeuse's death could inspire similar interpretations. This event could spark renewed interest in astronomy and space science, much as the discovery of the first exoplanets did in the 1990s. Regardless of the exact timing of Betelgeuse's demise, it is clear that its death will be a significant moment in both the scientific and cultural history of our planet. Ultimately, while Betelgeuse's potential explosion is one of the most exciting astronomical events on the horizon, it also serves as a reminder of the impermanence of the stars and the awe-inspiring processes that shape our universe. It is a humbling reminder of the grand cycles of birth, life, and death that govern the cosmos.